you very much, Andrea. Today's agenda is, at first, I just want to spend a few slides telling you what Camel is in case you don't know. But the focus of this webinar is very much about what's new in Camel 3 and all the Camel sub-projects we have today. And at the end, we have some insights into what's coming next in roadmaps and more materials. And we end this webinar with Q&A. But let's first start with what is Camel. Well, Camel is an integration framework. It's the Swiss Army knife of integration. It's also one of the most active and developed products at the Apache Software Foundation. It's been around for 12 years. And it comes with a lot of functionality, so you can kind of picture it's more like a giant Swiss Army knife. But what do you use Camel for? Well, you use Camel to integrate different systems. So many companies today have a lot of systems and they don't speak one language, so to speak. There's a lot of different networking protocols, there's a lot of different data structures and data formats, and you need to do data mapping and many other things. And how do you do that? Well, that's where Camel comes in, and you slot that in between, and Camel allows you to integrate different systems really easily. Now, Camel is a Java-based integration framework. It supports and runs on many of the very popular runtimes like Spring Boot, Quarkus, which we're going to talk about later today, Java Enterprise, Microprofile Specification, OSGI, Standalone, and whatever. It's also based on the idea of enterprise integration patterns, and it comes with a lot of components, which you can think of like connectors to connect to a lot of different systems. And in Camel, you define or to code how you integrate different systems using a DSL, which you can code in Java XML. If you've never seen Camel wraps before, then you're going to see them in the next slide. Here's a very simple sample of a Camel wrap. So we are connecting two different systems. It's a straight one-to-one integration between a file system and DMS broker. So we just say from file and the directory where to pick up the files and specify the queue name. And you can use that. In the top corner is the Java code, and in the bottom you can do that in XML. Okay, but this webinar is more about Camel 3 and what's new. Andrea, will you tell us more about Camel 3?
Yeah, thanks, Klaus. So let's talk about Apache Camel 3 and what has been done during the effort from the community about this release. So in Camel 2, Apache Camel was a mono project. So you have everything in Apache Camel, and in Apache Camel 3 we built an ecosystem around Camel. So the projects of Apache Camel 3 are the base one, which is Apache Camel, the integration framework. Then we have Camel K, which is the cloud-native application Camel version, and is a lightweight serverless integration platform. You may read the K as Camel on Kubernetes or Camel on Kinetic, but we will see this later in the next slide. Then we have Camel Quarkus, which contains the Camel extension for Quarkus, so the Quarkus support in the Apache Camel ecosystem, and is an optimized version of Camel using the GraalVM stuff. So this is another important part of the Apache Camel 3 release. And the latest project in the family, the newest one, is Camel Kafka Connector, which uses Kafka Connect API, so the Kafka Connect framework, combined with the functionality and feature of Apache Camel. Let's focus on what's new on Apache Camel 3 in the Camel 3 project, so in the core. This is the timeline of Camel 3. So we wanted to do a time-boxed release, and we want to do this in a year. So we switched to the master branch to Camel 3 in December 2018, and we released the GA in December 2019. So in the correct date. In the middle, we released multiple milestone release candidate with different features that I will show you in the coming slide. What was the Camel 3 goals in the beginning? So what we want to do is clean up of the technical debt that we have and tidying up the APIs. We wanted to modularize the Camel core and make the Camel core lightweight, introduce a complete reactive routing engine, and have a Camel main for the standalone support of Apache Camel as a separated module. We introduce also Fluent Builder for endpoint configuration and component configuration, and we try to make Camel 3 backwards compatible as possible with Camel 2. We introduce also Java 11 support, a new website, and the new projects of the ecosystem, so Camel K, Camel Quarkus, and Camel Kafka Connector. And also we move out from the main repo of Camel 3 the Spring Boot support, so we will be able to release Camel Spring Boot as a separated release from the core. Okay, one important stuff that has been done from Camel 3 is the new website, and this is something we are really proud of, because the old site was not aligned in terms of documentation and information, and the effort around the website was also being able to auto-update the documentation on each commit. So if we change something in a component, the documentation is regenerated automatically, and we are able to have the website live in minutes because we have a job that works on this stuff. Camel 3 platform runtimes. So Java 8 is supported, and sometimes in the future probably we will drop Java 8. Java 11 is supported from the first version. GraalVM support is there through Camel Quarkus subproject. The Spring Boot baseline version is Spring Boot 2 for Camel 3. We have the standalone Camel main introducing in Camel 3, the old OCI support to Apache Java, War and Java Enterprise support, and also the Eclipse microprofile specification support. So about the modularization of Camel core. In Camel 2, all the core stuff was inside the single jar. To modularize this, we split the core classes and functionalities in multiple modules, and in the end we have 34 components, 34 modules for this. You probably are wondering why we underline Camel API and Camel support. This is because Camel API contains the public API for the developers, and Camel support contains the building stuff to build custom components in Camel. So if you are a developer, probably you will use them more than the other. The other are internal part, more or less. In Camel core, in Camel 2, all the components were inside the same jar. We moved out all these components in single Camel core components, and those are part of the 34 modules I was talking about in the last slide. With Camel 3 you have two possible choices. You can use the Camel core and bring in all the 34 dependency of the Camel core, so all the jars needed, or you can use the Camel core engine, which contains the basic feature and the basic stuff needed for a jump start in Apache Camel 3. It's up to you to choose. In Camel 3 we introduced the endpoint DSL, which is type safe and is based on Java Fluent Builder style. In Camel 2, when you specify an array, you are providing a string. As everyone knows, a string is prone to mistakes. So one of the problems we faced in Camel 3 was being able to build the endpoint configuration through Java code, and this is what the endpoint DSL does. So you are still able to provide string as endpoint array, but you are also you have also the possibility to use the endpoint DSL as shown in the slide. We did the same for the component, and so we introduced the component DSL, which again is type safe and based on Java code builder style. For example, in Camel, one of the components with much more options, both on endpoint level and the component level, is Kafka. And configuring everything through the array in the endpoint is really complex. So the component DSL and the endpoint DSL are here to help. One of the points we would like to develop in Camel 3 was the reactive part, and Camel 2 is much more a semi-reactive approach to this paradigm, and in Camel 3 we make all the EAP fully reactive. Also we introduce a total non-blocking approach in Camel 3, while in Camel 2 we have a mixture of blocking and non-blocking. We have some features related to reactive one that we had to postpone, and listed in the slide, in particular the back pressure and the flowable API from Java 9, and this will be part of the next releases. In Camel 3, as I said, we move out Camel main, and this is for supporting a standalone approach. And this Camel main is used also in Camel K and Camel Quarkus. We will see them later. And you can also have a unified configuration in this case for Camel Spring Boot 2. And the idea is to have single application properties for the Camel main, like we usually have in a Spring Boot application. We have for the Camel main also tooling support for multiple IDE, so Eclipse, Shell, VS Code, and IDEA. In Camel 3 we support the Eclipse microprofile specification, and the top 3 part in the slide, so configuration, metrics, and out checks are already there. The other 3, fault tolerance, reactive messaging, and event tracing, will be part of the next release and are in progress. Other important stuff introduced in Camel 3. JUnit 5 support is one of the new features that we introduced. And another important one is the lazy start producer. So the idea is to avoid Camel to fail on startup if the producer fails to start. In Camel 2 we used to have a different approach, and the fail fast approach, and in this case we changed this behavior. Okay, so Klaus, let's talk about the optimization that have been done in Camel 3.
Thank you, Andrea. Yeah, certainly. This is also an area that I spent quite some time digging into and optimizing for Camel 3. So let's go over that. So one of the other great goals of Camel 3 was to make Camel faster and have lower footprint. One of the ways we did was to reduce the number of classes that Camel needs. For example, if you see here, we have an example where in Camel 2 it's more than 5,000 classes, and now we're below 4,000 in Camel 3. And we identified a few more points where we can improve for the future, so we are working on that for the next release as well. On top of that, we've done many smaller optimization inside Camel Core to make it even smarter, faster, and smaller. One of the big things we did was to also avoid using Java reflection as much as possible. So in Camel 2, when Camel start up and configure itself, all the bulk configuration endpoint and components and also type converters that happen at runtimes are actually using reflection based on loose coupling. Now in Camel 3, we have been able to source code generate configure classes for that. That means everything is now a static Java calls and there's no reflection going on. That allows Camel to actually be faster at startup and use less memory, and also much faster at runtime because there's no reflection overhead. And on top of that, that also works much better in the native compile world with GraalVM, where you can't do reflection. We also introduced the additional lifecycle phase on Camel service, so you can have a build phase and an initialize phase. This allows Camel to do some additional work on building. So when you build your projects, then products like Quarkus can leverage that and do some build time optimizations that allows Camel to do even faster, smarter things. Excuse me. Another thing we did was to make JMX totally optional. So, for example, on the cloud environments, you typically don't use JMX, then there's no need to have it pressed at all on the class path. Okay, next slide. Yeah. So in the latest release in Camel 3.1, we focused very much on reducing unnecessary object allocations, and we're going to see the next slide, but also to reduce Camel the code execution path to avoid calling too much code which wasn't needed, reduce memory and other times, and to optimize critical code paths of Camel. I think the slide speaks for itself. So this is a slide showing the average object allocation per second going on. That means a lot of the objects that are allocated on the heap that Camel allocates during processing message. This is from an example where it processes 1,000 messages per second. And as you can see, something in the middle. Lower is actually better, so something went really wrong in Camel 3. So 3.0 was using way too much objects, and we were able to optimize that quite a lot. So we are able to get that 50% faster than in Camel, the latest Camel 2 release. So what I'm saying is that if you're using Camel 3.0, please update to 3.1, and you'll get a great Camel again. This slide shows the unique method calls that Camel performs while processing the entire message. So from the start to the end, how many different methods are actually being in use in Camel. And you can see in Camel 2 it's 139. There's some more in Camel 3.0, but not too bad. But then we optimized to half that in Camel 3. And we identified a few more spots. So, more will come there in the future as well. But all of that is really awesome. It is really making Camel smaller. And together with the modelization of Camel, we can make Camel really small and nimble for the cloud environment, for example. And speaking of the cloud, then we have the new product, Camel K. So what is that? So Camel K is a lightweight integration platform based on Camel, born on Kubernetes with serverless superpowers. Yeah, I repeat slides. I really like that tagline. So with Camel K, you can run it on vanilla Kubernetes, but you can also run it, for example, on OpenShift. And you get the best power with Camel on a Knative powered cluster, which you can install on Kubernetes or OpenShift. So what's the idea with Camel K and how do you do it? So the idea is Camel K is targeting the low-code, no-code movement, for serverless and lightweight integration, where as a developer or maybe another person is doing some sort of integration, but you don't want to stand up an entire Java product. You just want to focus on the integration and don't care about the runtimes, and you just want to let it running in the cloud somewhere. So you want to focus just on the integration logic. And in Camel, with Camel K, you can do that in a single file, and this is a Groovy file. So in this example, you're saying if we receive message from a Telegram bot as a chat system, do some message transformation, sending that message to a Kafka topic, and then listening for the same topic and sending calling it to this service. So that's just a single file. Then you can say the camel run and the name of the file, and then it runs in the cluster in the cloud. Okay, so what's the high-level architecture of Camel K? So on one side we have the developer environment, and then on the other side the remote cloud is the cluster, the cloud. So Kubernetes allows to extend itself using something called custom resource definition. So what we've done with Camel K product is to create a number of custom resources for integration, Camel. So what happens is that inside the cluster is an operator, a Camel K operator that monitors these custom resource definitions and react upon them. So the idea is that you can sit in your development environment, write your integration code using a command line tool, for example, to upload your integration into the cluster using as a custom resource definition. Then the operator reacts and they figure out what to do. So all the smarts and the intelligence are inside the operator. It figures out what kind of code integration you're using and building a Docker image and whatnot if that's necessary, and how to figure out how to run that as a running pod. And you can do that really fast, sometimes in less than a second. So, and here's a slide presenting some of that. So one of the great goals of Camel K was also to make it fast to run workloads in the cloud really fast. One of the problems was that every time you do a code change or some sort of change, then because of the immutable container Docker image, you had to rebuild the entire new image, and that takes the same time all over again and again. That's why the bars for red, yellow, and green are the same, but in the blue one is Camel K, and you can see on redeploys it's really fast. So where can you find Camel K? Of course you can find Camel K on the Camel website, on GitHub, but there's also something called an operator hub. So it's a website where you can find operators that you can easily install inside your Kubernetes clusters. And there are different operators for databases, Kafka, and many other things, but there's of course also one for Camel. And speaking of that, let's see Camel K in action. So we have a little video, a demo of it. So in the top corner we have the source code, a camel route from a timer to a log, and then two terminals in the bottom. On the right-hand side we have a watch where we watch the pods, and the other left-hand side are using the terminal. So let's go here. So I am seeing the Camel K examples. If we download it from GitHub, on the examples you can find examples. Over on the terminal I say queue get pods in watch, just to watch the activity on the pods. So we can see the Camel K operator is running. I go back to the terminal, and now I want to start Camel integration. So with the Camel command line I can just show you the version. It's RC1. And then I can say Camel run, and the name of the file is a Java file, for example, sample Java, and then in dev mode /dev, that means it will tail the log so I can see immediately what's going on. As you can see, Camel K is running now. It says hello Camel K, and I could go up here in the source code and I can change the source code to say bye Camel K. I save the file, and now pay attention what happens. As you can see there, it redeploys Camel K, and over the container file you can see the pod is terminated and a new one is started up. So Kubernetes is starting up a new container, a new pod with your code changes. That's really fast. And if I do a coding error, you can see you will get a compiler error in the terminal. And remember, in the top, I'm just using a text editor subline. It's not a full-blown Java editor. It's just a single file, even though it's Java. And I can also configure input parameters. Now let's make it run faster, for example, the timer. So it's every 12 milliseconds instead. And then it just goes like that. So that was a very quick demo of Camel K. Camel K warrants itself in full entire webinars, where we can also go more in depth with Knative and other things like that, with scaling and so on. So stay tuned and look out for more webinars coming from that and that subject. But we are moving on to another great things coming in Camel 3, which is Camel Quarkus. So Java has been around for 25 years, but it's known for a thing to be a bit slow, especially in the cloud native. It has a density problem. This is a huge problem with Java. So alternative workloads written in Go or Node or something like that, you can stack and compact a lot more Go applications than with a typical Java application. Even a modern traditional cloud-native Java stack is hundreds of megabytes, 150, 200, 300, 400 megabytes, even with the, let's say, latest Spring Boot and so on. So that's the real problem. Another problem is that Java is a bit slow to start up. It takes time to warm on. It takes time to load all the classes and everything it needs to do. The JVM is, built for a different time where you start up a single process and keep it running for as long as it could. Whereas on the cloud, it's more the opposite. You just want to write microservices or functions as tiny as possible and only run them when you really need it. So you need a way to scale them up quickly and scale them down again, but also very importantly, scale to zero, which allows to scale down and don't use resources when there's no need for it. And when there is demand for it, some web users come to a shopping website or something like that, and then there's suddenly demand for a service, then you can quickly scale them up. So how can we do that with Java? And ta-da, this is where Quarkus come in. This tries to be a solution for that and other things. But if you go to the Quarkus website, they have a tagline that says it's a supersonic subatomic Java. Okay, what the hell is that? Well, it's actually a Kubernetes cloud-native Java stack. You can run with native compile using GraalVM, or you can also, very importantly, just run it optimized on an OpenJDK, and it supports the best Java libraries and standards. For this webinar, we're just focusing on the small footprint it has. It has a really minimal footprint. So this is from the website. They have a comparison between a traditional cloud-native stack. This is the gray ones. So for example, in memory, the REST service is 136 megabytes in memory. Just by using Quarkus in JVM mode, by just adding Quarkus to your product and have its main plugin to do some smarts and things or not, you can cut the memory usage in half. And if you can native compile that, you can get it down to 12 megabytes. So a lot of savings in memory, but also very importantly is that Quarkus can help to be really fast on the first response time. That's part of the scaling. So you can boot up really quickly and then handle traffic. The traffic comes in, and then you can process that traffic and send back a response. So a REST service, and for example, with a CRUD operation to insert data in the database, Quarkus is much faster than alternatives. And this is really important for Quarkus or Java itself. So if you don't know about Quarkus, I highly praise this product. It's really one of the best things that's happening in a long time in the Java ecosystem. Go and take a look at that product. And we have also a couple of demos with Camel and Quarkus. One of the slides here shows that if you can native compile a Camel with Quarkus, you can get it to start up really fast, 13 milliseconds. The binary size of the native compile is still a bit too big, I think, but the room is 68 megabytes this example, and the memory usage is only 16 megabytes, and that's the residence set. That means the total uses of memory, so it's heap and all the other things together. So that's the true message. But now let's go and see some demos, and I would like to show you first my favorite camel is the Lego camel. I'm of course from the land of Lego. So in the first one, we are actually from the Camel Quarkus website on GitHub on the examples. There an example called timer to log. This is a simple example, but it's a good one to start with. So what I've done is to check out that source code and open that in the editor. This is Visual Code. And up here you can see the route is just a timer and a log. And it triggers every 1 second. And I have a terminal. I say maven compile Quarkus:dev. That means I compile the source and then I run Quarkus maven plugin that runs in developer mode. That allows me to do debugging and other things, but more importantly, I can actually do code changes, just like in Camel K you saw before. Now I say buy world, and it does a hot replacement immediately. Yes, we can see the constant update immediately in the log below. And I can also change parameters. The timer, for example, now goes quicker, and all these kind of things. So this is really awesome. Also, another thing I wanted to show is that Visual Code, we also have tooling support for Camel. As you can see, I can get tooling assistant, what options you can specify in the timer endpoint. For example, the period, I can see the documentation for that as well. The default value was 1000, I can change it to something else and save it and so on. So that's really nice to get support out of the box from the tooling if you install the Camel extension in Visual Code. And also you can get a list of all the Camel components in the tool. You can see the Amazon components, there's also going to be Google components and many others coming on. As I said, there's about 300 or so. And you can get the list from the tool immediately here. Okay, so let's move on and see another example. So when you work with Quarkus, a good way to get started with Quarkus is to go to the Quarkus website, and there's a button called Start Coding. And then you can, jumpstart a project where you can specify group ID artifacts and choose Maven or Gradle. And let's build a Camel example. Of course, all you see on the website, these are all the standard Quarkus extensions you can choose, and you can choose many other things than just Camel. But I am building a cloud-native stack, so I'll have some health checks, and I'm actually looking for the metrics. It seems I can't find it, so there's a search box. I can just type metrics, and I can find, okay, small mile metrics, okay. And now I want to add some Camel extensions to it. And it comes down in the integration section, in the Camel core. And then we're going to choose the microprofile health and metrics, so we get that out of the box as well. And I want to integrate with the HTTP server Quarkus, so I'm looking for the platform HTTP. There it is. I'm choosing that one. What I can do now is just to click the blue button, generate your products, and then it will download a zip file for me with what I've done. And of course, I've already done that, so I'll switch into my editor, and I loaded up the product here. What you get is a standard hello REST service from out of the box saying hello, hello. And then I added a route, Camel route, my route class that extends the route builder from Camel. And then I added a CDI annotation that allows Quarkus and Camel to detect this class and also include the Camel route. Then I say platform, from platform HTTP, hello Camel, and then I say Camel runs on, and then I want to get the host name, which I'm using a utility class for. So I'm switching to the terminal to allow to run this example. I already, of course, compile it, so I can start in the single jar, Camel jar, and there's a runner Java. That's runner jar. And if I run that one, it starts up the application in JVM mode in 1.3 seconds. That's quite fast for starting up a HTTP REST server and with health checks and everything included in a JVM mode. And I can go to localhost 8080, and you get a front page from Quarkus. Yay, everything is working. I can say hello, I get a hello response back that was in the source code. And I can also call Camel, hello Camel, Camel runs on, and that's my computer. And also have health checks, so if there's less health, I can get the health checks, the status is up, and I can see that Camel is integrated with the liveness checks and readiness checks and everything. And I can get the metrics. And for example, you can slip them into Prometheus and Grafana and have visualization and everything. and I can see that the exchange the total, that means the number of camel messages processed, that's 1.0. And if I call it again with camel, hello camel, now the number should go from 1 to 2. Now it says 2.0, so you have, live messages and everything. And I have a little script that should, I'm no wizard on the script, but I have a little script that can get the memory use from that application, resident set. So the total memory uses, and it's 198 megabytes. That's quite a lot. It's a bit embarrassing. It shouldn't be that high but we haven't, configured anything on the JVM. You can set heap sizes and everything. It's just, by default it executes and want to have like 4 gigabytes and so on. So it can use a lot of memory. Now I precompiled the native one, and it starts up in 20 milliseconds. And again, I can also get how much memory does the native one use, 20 megabytes. So of course much less. And I can get the same from the native one, health checks and so on, call camel and so on. So everything is good there. So what I'm going to do as well is to run many. So what I'm going to do now is to run 100 of these camel applications, the native ones, from port 80,000 to 8,100. So now I start the script. They're all running now. If I get the sum of all the memory they're using, they use 1.8 gigabyte of memory. So about 18 megabytes per instance. And I can pick a number, 80, let's choose 44, hello, camel, and of course it runs, and I can choose another number, port number, 96, and I get a response back. Now I can kill everyone, process kill, like, hey, everyone is dead, the website is done, I can start them again, and I go and I've refreshed the browser and I get immediate response. So fast it is, that's amazing. Okay, but go and check out Camel Quarkus and Quarkus itself, that's really a great thing. So, Andrea, what's up with this Kafka thing?
Thanks, Klaus. So let's talk about the younger and latest project in the Camel ecosystem, which is Camel Kafka Connector. So as an introduction part, let's talk about Apache Kafka. What is Kafka? Basically it's a distributed stream platform and also a PubSub messaging broker. Much more is an ecosystem like Apache Camel. It's composed of multiple components like Mirror Maker, the Kafka Connect API, Producer API, Consumer API, and so on. So, and also it has a lot of third-party integrations. One of the components of Apache Kafka is Kafka Connect. What is exactly Kafka Connect? It is a framework that helps to integrate Kafka with other systems and external systems, like for example database or messaging platform, messaging broker, and so on. And through the Kafka Connect, we are able to ingest data in Kafka and get data from Kafka. So a user can define a source and a source or sync connector to send data in and out Kafka broker. These connectors are pluggable, so you can use them. You can use one of the many connectors available from multiple marketplace, or you can write your own Kafka connector. So the Kafka Connect framework is distributed and scalable by default. It has an automatic concept management, and also it supports simple transformation and streaming batch integration. What are the key concepts in Kafka Connect? The connector is the source and sync created through the Kafka Connect API. The sync connector and source connector are responsible for setting up the connector and the partitioning of the work. And to do this, the sync and source connector will create a sync task and source task, that are responsible for the actual work. So they will handle the the real work. Also in Kafka in general, and also in Kafka Connect, there is the concept of key-value converter. A converter is just a class that is able to convert the key or value of a Kafka message from a format to another, and this is important when you are ingesting data from Camel to Kafka, or in general from an external system to Kafka. Also there is the concept of transformer. The transformer is a class able to manipulate a message coming to or coming from Kafka. Kafka Connect framework can work in standalone mode, and you will have in this case only a single connect worker, and the configuration and the offset will be stored locally. Otherwise, it can run also in distributed mode, and in this case you will have multiple connect workers. These workers will share the work, and the configuration and the offset will be stored in Kafka. In this case, you will have also the concept of leading. So one of the worker will be leader, and you will have also the balancing of the task between the workers. But what is Camel Kafka Connector in the end? It's a big Kafka connector built on top of Apache Camel. So the idea is that using what we already have in Camel, we could be able to build a connector for each component. So you will get 300 connector for free, more or less. This idea has been started as an internal concept in Red Hat, and it is now as a project of Apache Camel. It was donated by Red Hat in December 2019. And the idea, as I said, is to reuse in a simple way Apache Camel as Kafka Sync and SUS connectors. This slide is about the available connectors. In reality, this is much more a slide showing the connectors that have been extensively tested, both with integration testing and with unit testing. We are confident that also other connectors are already working, and we are working on trying to make the integration testing systematic. This is something that is part of the roadmap that we'll see in the coming slide. But let's see how Camel Kafka Connector works. I will show you a demo of Camel Kafka Connector from AWS S3 to JMS. In this case, so we will use the S3 SUS connector through the Camel AWS S3 connector of component of Camel 3, and the JMS sync connector from the Camel SJMS2 component from Camel 3. The idea is to load the file in an S3 bucket and send the file content into a JMS queue using in the middle Kafka, and using the SUS connector and sync connector related to the components involved in this. So let's see. Okay, this is the GitHub project with the Camel Kafka Connector demo. This is what you need. I already had Kafka running and in my project and in my machine, so I have everything there. I also run the Tennis Broker already. Here you will see the console, and we will point my queue, and also I have the S3 bucket already there, so we will be able to load the file in the bucket. Let's see the properties of the SUS connector. We have the class for the SUS connector, the converter that we will use for the key, and the components option. On the other side, we can see what we have to do with the option for the JMS sync connector. So we have the name for the connector, the topic pointed, other information about connection factory, and the URI of the Camel endpoint. Okay, now we're switching to the current branch with the real option. Okay, let's build the package with everything we need. So we will have everything to add to our class path. We export to the class path, and we run the Kafka connector with the connect standalone executable, the connect standalone properties, and the S3 source connector properties. We do the same for the JMS sync connector, so we have already everything in place. Okay. Both of the connectors are running, so we have the consumer on the S3 side, which is pulling the bucket, and on the other side we have the JMS producer that is already running. Okay, what we want to send, we want to load the file with the load from Camel Kafka Connector, and we are loading the stuff in the S3 bucket, so we're already there. In this case, we have already the file there, but the S3 component has the delete after read option already set, so it will be deleted. On the other side, we should find the message in the JMS MyView queue. We have here the message we told header and information coming from Camel and from the JMS producer, obviously. And now we can browse the queue. We have only one message here. And as you can see, the button is hello from Camel Kafka Connector. Okay, this is the log from the source connector for S3. As you can see, the offset has been connected. Okay, and this is for the JMS sync connector. Okay, this is more or less how the Camel Kafka Connector works. And let's talk about the roadmap clause, right?
Yes, thank you very much, Andrea. So let's take a look at the roadmap for the upcoming Camel 3.2 release. So I have mentioned it before, we'll continue doing optimization inside the Camel core. We identified a few places where we can even modelize Camel core more, so maybe we get more like 35 or 36 modules instead of 34. There was one last thing to do with the reflection-free component configuration, and we also want to implement more Eclipse microprofile specs, and we want to allow third-party components to also be able to generate endpoint and component DSLs so they can use that as well. For the Camel K roadmap, then it's a little bit behind the latest Camel release, so we are working on adding support for the latest Camel 3.1. It will have, of course, all the goodies from 3.1 with the lightweight and the reduced memory footprint. There's also a webhook component to allow better to scaling to zero. We also want to have first-class support for Quarkus as a runtime. And then Camel K is closely following the Knative approach or the specification, and they are not yet on 1.0, but they are closing in on that. So when Knative goes 1.0, then we are good to go and be able to also do a Camel 1.0 release. There's some other things coming in, better tooling support, and we're also working on a solution for doing testing. And the last thing I want to talk about for the roadmap before handing over to Andrea is the Camel Quarkus thing. Camel Quarkus is really awesome as it is today, but we have still identified some places where we can improve the setup. There's also some places where we can do a bit more build time optimization, but the bulk of the work will be to build more extensions or migrate more of those 300 Camel components. So far we've done 65. Okay, Andre, what's the roadmap for Camel Kafka?
Yeah, thanks, Ross. So the basic stuff we want to do is having a stable release, the first stable release, because actually we don't have the first release. So we want to release the 0.1 first version of Kafka Connector with inside the connector auto generation feature. We are working on that, so being able to update to a different version of Camel and getting all the new options and all the new stuff and components to set for free. So through a Maven plugin, we are working on that, and it's a big effort. And the other main developer of this project, that is Andrea Tarocchi, is working on that with me. We want also to introduce the systematic integration testing I was talking in the first slide, plus general improvements and also much more evangelism around the Camel Kafka Connector, so more blog posts, news articles, and conferences too. It's one of the projects that new contributors may try to approach to help Camel and improving the community and improve the ecosystem.